Sound waves are a form of energy transmission. Therefore, it is necessary to measure sound using physical quantities such as sound power, sound intensity, and sound pressure. Sound power refers to the sound energy radiated by the sound source per unit time, and is the output power of the sound source. In watts, it is regarded as the characteristics of the sound source itself in the sound environment design, so it does not change with the different environmental conditions. When the frequency range is limited, it is called the frequency band sound power. Sound intensity is a physical quantity that measures the sound intensity of sound waves in the process of propagation. The sound intensity of a certain point refers to the sound energy passing through a unit area perpendicular to the sound wave propagation direction at the point in unit time, and the unit is watt per square meter. Under ideal conditions, that is without considering reflections in the environment and attenuation in propagation. For spherical waves, the sound intensity is proportional to the sound power of the point source and inversely proportional to the square of the distance to the source. For plane waves, the sound intensity is constant regardless of distance, but in reality, sound energy is always lost, and the higher the frequency, the greater the loss. Sound pressure refers to the change of the pressure in the medium when there is sound wave propagation in the medium relative to the static pressure of the medium when there is no sound wave. Therefore, the unit of sound pressure is the same as that of pressure, both Pascal. Since the sound pressure varies with time, the root mean square of the instantaneous sound pressure within a certain period of time is used as the effective sound pressure, and usually the sound pressure refers to the effective sound pressure. The effective sound pressure of simple harmonics is equal to the maximum instantaneous sound pressure divided by the square root of 2. Since sound intensity is difficult to measure, the sound intensity and sound power are usually calculated by measuring the sound pressure and using the relationship between the sound pressure and the sound intensity. The relationship between sound pressure and sound intensity is: in the free sound field, the sound intensity at a certain place is proportional to the square of the sound pressure at that place, and inversely proportional to the product of the medium density and the sound speed. Among them, the product of medium density and sound speed is called medium characteristic impedance. Sound energy density is used to describe the intensity of sound energy per unit volume in joules per cubic meter. Since it has nothing to do with the propagation direction of sound waves, it is suitable for analysis and calculation of reflected sound. The sound energy density of plane wave is equal to the sound intensity divided by the sound speed. Since the allowable sound intensity range of the human ear is 1 trillion times, the sound pressure difference is 1 million times, and the variation range of sound intensity and sound pressure is not proportional to the change of human ear perception, but is approximately proportional to their logarithmic value, thus introducing the concept of level for relative comparison is a dimensionless number. The sound intensity level and sound power level are divided by 10 times as a level, and the sound pressure level is too small, and 20 times as a level. The unit is 1/10 of a bell, called a decibel. The various levels in decibels have only the meaning of relative ratios, and their values are related to the reference value. Using the concept of level, the number level of the range can be greatly reduced, and the simplicity of the calculation can be improved. The sound intensity level is a logarithm of the ratio of the sound intensity to the reference sound intensity multiplied by 10. The reference sound intensity in the formula is the lower limit sound intensity value that the human ear can just hear to the sound of 1000 Hz. The corresponding sound intensity level is 0 decibel. In the free sound field, when the medium characteristic impedance of air is equal to 400, the salt intensity level and the salt pressure level are numerically equal. Since the characteristic impedance of air at room temperature is approximately 400, it is generally considered that the two values are equal. It can be seen from the definition of salt pressure level that a 10-fold change in salt pressure is equivalent to a 20 decibel change in salt pressure level. The reference salt pressure in the formula is the lower limit salt pressure value that the human ear can just hear to the salt of 1000 Hz. The corresponding salt pressure level is 0 decibel. The salt power level is the logarithm of the ratio of the salt power to the reference salt power multiplied by 10. The reference salt power is equal to the reference salt intensity value. When several different salt pressures act on a point at the same time and the interference effect is not considered, the total salt NZ density at the point is equal to the sum of the individual salt NZ densities. Likewise, the total salt intensity is equal to the sum of the individual salt intensities. The total salt pressure is then equal to the root mean square of the individual salt pressures. The total salt pressure level needs to be calculated according to the logarithmic law. From the superposition calculation formula of the salt pressure level, it can be seen that the superposition of two salt pressure levels with equal values is only 3 decibel higher than the original, not doubled. Due to the logarithmic operation, if the difference between the two salt pressure levels exceeds 10 decibel, the additional value does not exceed 1 decibel for the large salt pressure level, and the small salt pressure level can basically be ignored. This conclusion also applies to the superposition of salt intensity level and salt power level. Now, let's do two exercises. Know the frequency band salt pressure level of a certain noise and find the total salt pressure level. Since the salt pressure levels of its frequency band are not equal, the calculation formula of the superposition of salt pressure levels with different values is used, and the calculation is approximately equal to 102 decibel. Find the total salt pressure level after 10 equal salt pressure levels are superimposed. Since its salt pressure level is equal, the superposition calculation formula of the salt pressure level with the same value is used. Although the value of a single salt pressure level is not given, it can be calculated to be 10 decibel higher than a single salt pressure level. You can use the salt pressure level superposition calculation method to test the various rooms to see if the selection of equipment exceeds the standard. Can you also think about whether it is possible to run the same number of devices day and night? How to use the calculation results to design the envelope structure?